The discriminant of a quadratic function is the quantity that can tell us whether or not we have x-intercepts. Remember, the graph of a quadratic function is going to be a parabola, and if you want to find the x-intercepts, we would need to plug in 0 for y and solve for x. Plugging in 0 for y and solving for x leads to this quadratic equation, and the solution to this quadratic equation set to 0 can be found by using the quadratic formula, which is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is the value that's underneath the radical in the quadratic formula. If that quantity is greater than 0, then we're going to have a positive number under the radical, and we'll have two real solutions to this quadratic equation, which means that we'll have two x-intercepts. But if the quantity under the radical is negative, we'll be taking the square root of a negative number, and the solutions to this equation are going to be complex. If we have two imaginary solutions here, that would mean that our quadratic equation does not intersect the x-axis, and we would have no x-intercepts. If the quantity under the radical turns out to be exactly 0, then we get x is equal to negative b plus or minus 0 is still going to be negative b divided by 2a. So the only x-intercept that we would get in that case is the x value that is the vertex. Let's recall that the vertex point is situated at the ordered pair negative b over 2a, and then the function evaluated at negative b over 2a. So in that situation, we would only have one x-intercept.